Hey everybody, in this lesson we're going to talk about technology. So the big idea here is technology has helped progress our understanding of space and space travel. So we're going to start off with what are telescopes? Well, the telescopes we're going to be talking about right now are what we call optical telescopes. So optical. The word optical means vision. So a lot of times when we talk about telescopes, we're talking about things we can see. So when we talk about optical telescopes, we're talking about two types. We call them refracting and reflecting. Now these are two terms you would have remembered from grade 8 science when we talked about optics, where refracting is when it bends light and reflecting is when it reflects light or bounces light back. When we talk about these two types of optical telescopes, we're talking about them how they work. So refracting telescopes uses lenses to bounce light into your eye, while reflecting telescopes uses mirrors. Now the largest telescopes we have are mostly reflecting. So some of the largest, because they give you a way better picture. An example of a large telescope is, well, the ELT, which stands for the European Extremely Large Telescope. It can capture about 100 million times more light than our eye. It's about 129 feet in diameter, the mirrors that it has, and it's just a massive telescope. Then what are the other types of telescope? Well, if we have optical telescopes, we also have non-optical telescopes. Non-optical telescopes basically captures the non-visible electromagnetic radiation. Some examples of that could be, for example, radio telescopes. So here are some examples of pictures. So this is an optical telescope. This is your standard telescope that you have at home that you might look into the night sky. These are what scientists might use to study space. So this is an example of the Hubble Space Telescope that's out in space. But these are what we call non-optical telescopes. This is a radio telescope meant to capture anything that's in the non-visible region of space. So we talk about satellites, though. What are satellites? Well, we know satellites in space are objects that orbit a planet, for example. So a moon is a satellite. But what are satellites, the ones we invent? Well, first of all, the Earth has a lot of interference and distortion from the atmosphere. So our atmosphere creates a lot of issues that scientists don't like to be under because they want to be in the vacuum of space to observe space. So what happens is satellites allow us better better observation of space. And what they do is they orbit around the Earth, above the atmosphere. So they could do many things. These satellites have many functions. Examples, we have weather satellites that track our weather. We have television. We have communication satellites. And we also have GPS satellites. Now, satellites that remain over a fixed point, those are called geosynchronous orbits. So satellites that orbit around the Earth at the same speed as Earth's rotation is called geosynchronous, aka it will remain above the Earth on a fixed point. So to you, it looks like it's not moving. So that's what we call a geosynchronous orbit. Now, what are probes then? Because there's something called a probe. Well, a probe is defined as a space vehicle sent to other celestial bodies to study. So they're sent to other celestial bodies to study. They could fly there, fly past, they could orbit, or they could land. And because they are sent to far, far places, they do not need a crew. Because they aren't going to return back to Earth. Examples of this is what we call one of the most famous one, the Voyager 1. The Voyager 1 space probe is a space probe that was sent out into space about 40 years ago to be a treasure chest for Earth. It was meant to study different planets, but as it went past Pluto, it contained a treasure chest of all things that we want other species or other beings to find if we ever have it. So inside of it has a record of different types of music. It has a map of our solar system of where our Earth is located, and you can actually see its mission status of Voyager 1. You can see that Voyager 1 is approximately in its 42nd year of existence. It's about 140 astronomical units away from the Earth. It's moving at approximately 38,000 miles per hour, and it takes light about 20 hours to reach it. So that's a really far time. Light, as fast as it's traveling, still takes 20 hours to reach Voyager 1. So that's Voyager 1. Well, how's that different from rovers? Rovers are human replacements on a planet, for example. They they conduct experiments. So they replace humans, for example. And you could think of them as small, movable probes. An example of this one of the most famous rovers is Curiosity, which was sent to Mars about 10-ish, 15 years ago to explore Mars. And you can see this is what Curiosity is. It has a lot of scientific equipment on it to study the ground of Mars. So what are some other technologies of space travel? How do we get to these places? Well, definitely one of the most famous one is rockets. Rockets are basically explosives to create thrust. We need to get out of the Earth's atmosphere, so we need to use explosives to create thrust. Now, back in the day, we used the Space Shuttle program. And this program was costly because the rockets that were used to send the space shuttle to the International Space Station would fall back on the Earth and not be reused again. So only the payload survived, but the space shuttle itself got reused. So that sort of saves some energy. But now we have reusable rockets. We have some reusable rockets that are available. We'll talk more about it. Some other space travel, we have the International Space Station, which is a laboratory up in space that we use, that all the international nations all combine together and try to conduct experiments up in zero gravity. And what this International Space Station is it basically orbits the Earth at around 27,000 kilometers an hour at about 350 kilometers altitude. Now, because it's still pretty close to Earth, it has gravity still affecting it. But because it's what we call free fall. Now, if you want to know more about free fall, what you can do is you could Google free fall and understand what it means. It just means that when something's falling, it's falling beyond the edge of the Earth, and thus it, in a sense, it's orbiting the planet. And this is an image of the International Space Station. It's a giant science laboratory. Now, what are some rewards of space travel? Well, one of the biggest rewards is many inventions came from space travel, which we use today. We call these spin-off technologies. That means they were meant for one thing, but now they're used for others. So examples of this would be, for example, freeze-dried food. Computers. High-tech clothing. But there's other rewards as well, such as, for example, space tourism. Because that's a big field we have right now, that people want to go to space, and that's a big field we have, as well as terraforming, aka transforming another planet into a livable planet. But even though there's rewards, there are risks. There are huge risks of space travel. One of the biggest risks is equipment failure. And you might remember that first of all, when you're up in space, you have no place to land. You're up in space. But the other part is the fact that the rockets can fail. And the rockets are explosives. And if that fails, you have a huge issue on your hand. An example of this would be the Space Shuttle Challenger. The Space Shuttle Challenger was a space shuttle that was launched in around 1980. Let's see, Space Shuttle Challenger was launched in 1986, and it exploded in the midst of its launch. And that was a big risk of space travel. There are other risks of space travel. Another risk, space debris. Oh, you have too much debris up in space, you can cause a lot of damage. This can damage other spacecrafts, or it can fall back to Earth, and that could be damaging as well. Now, most of these space debris is actually monitored at all time, so that's the good thing there. The last thing is there's a lot of ethical reasons, such as, is it worth it to go to space? So the money part. There's environmental. is it necessary? And the last one is political. Who owns space? Now, even though we have all these issues about space travel, we have some new technologies that have come to play to allow us to um, make space travel easier. The first one is reusable rockets. Now, you might know of, for example, SpaceX. SpaceX is a company run by Elon Musk. You might know of him from Tesla, and he started a reusable rocket program we call the Falcon program. This is called the Falcon Heavy. These three boosters are rockets, the payload's up there. And these three rockets can land themselves. So if you search up Falcon Heavy, you can actually watch on YouTube these three rockets landing on their own. There are other types of new technologies, such as, for example, space sleds, which can help accelerate a spacecraft without rockets. Of course, the last thing is space elevator. What if you can build a space station and only have it connected to an elevator, which allows you to launch things into space using just an elevator? These are all ways we could make space travel a lot easier and hopefully less cost effective and more environmental as well. As always, make sure you keep yourself safe and healthy, and I'll see you soon.